Hello everyone, myself Mr. Jangle Sanket Surendra, lecturer from Mula Education Society's Mula Rural Institute of Pharmacy, Sonai. Today we will discuss the chapter Environment and Health from the subject Health Education and Community Pharmacy, which is of first year diploma in pharmacy or helpful for first year diploma in pharmacy students. Objectives of environment and health. First, sources of water supply, water pollution, and methods of water purification. Second, air, noise, and light pollution, their effects on health. Third, solid waste disposal and their controls. Fourth, arthropod-borne diseases and their control. We will start with the first point, that is sources of water supply. The main sources of water supply are rainwater, surface water, groundwater and seawater. Now we will see one by one. First of all, rainwater. Rain is the primary source of all water. It is the purest water in a nature. It is clear and very soft water but tends to become impure as it passes through the atmosphere. Surface water. It originates mainly from a rainwater. Majority of Indian cities and towns depends upon a surface water. Surface water is stored in it consists of reservoirs, rivers and tanks. Means those rainwater which falls on a surface and flows, it is known as the surface water, and then it is stored on a surface, means in a reservoirs, or it flows from the rivers, or it is stored in a tanks. Okay, first one, reservoir. These are the artificial lakes constructed usually with earthwork in which large quantity of water is stored. Water from reservoir is of fairly good quality. It is usually clear, palatable and soft water. B. River. Many cities depends on their water supply on rivers. The river water is usually polluted with sewage, industrial waste, man and animal washings, etc. Third one is the tanks are the large excavation in which surface water is stored. It is contaminated by silt, colloidal material, washing of humans and cattle. Because of high degree of contamination, tank water is not suitable for drinking. Third one is the groundwater. The part of the rainwater which sinks into the ground and reaches subsoil to varying depths is known as the groundwater. It is naturally filtered through a ground. The usual groundwater sources are wells and springs. First one, wells. There are different types of wells like shallow well, deep well, tube well, artesian well, etc. B. Springs. Springs are natural outlets of water held under pressure by the impermeable layer. It comes out at places where the geological conditions are favorable. Seawater. Distilled seawater is used for drinking purposes. For aeration of the distilled water, it may be passed through a long column of wood, charcoal. Subsequently, it is tasty and can be used for a drinking purpose. That was the sources of water supply. Now, water pollution. It is defined as the contamination of water resources such as lakes, rivers, groundwater, ocean, etc. Or it is a water with altered taste or having smell or color. It's called as the water pollution. Various types of contamination of water and their effect on a health are as follows. First one, urbanization and industrialization. Rapid urbanization and industrialization is posing much greater risk of water pollution and it is dangerous. The water from sewage system may pollute water which might contain pathogenic microorganisms. Waste products of industries and agriculture waste contains pathogenic organisms and toxic chemicals like pesticides, fertilizers, radioactive substances and some complex organic chemicals. Second one, biological pollution. Water pollution caused by microorganisms such as infective agents or an aquatic host is called as biological pollution, and the disease caused by such water are called as waterborne diseases like hepatitis, diarrhea, amoebiasis, etc. Chemical pollution. Water contaminated by waste product and chemicals used in the industries includes detergents, cyanides, heavy metals, ammonia, sulfides, etc. Chemical pollution is very harmful because once the chemical starts get mixing with the water, it becomes continuous process and sometimes the toxic effects are not immediately noticed and community which is using this water have a long-term irreversible toxic effect. If such water is consumed by aquatic animal or used in agriculture, the consumer which are taken these crops, fruits, animals like fishes will also affect on a consumer. Waterborne diseases, their prevention and control of water pollution. First of all, we will see the waterborne diseases. Consumption of contaminated water with the pathogenic microorganisms leads to so many diseases known as waterborne diseases. They are classified as bacterial disease, viral disease, protozoal disease, worm infections and disease due to toxic substances. Bacterial diseases includes diarrhea, dysentery, typhoid, paratyphoid, cholera. Viral disease, it consists of poliomyelitis, viral hepatitis, etc. Protozoal diseases, which consist of amoebiasis, worm infections such as roundworm, threadworm, and those diseases which are due to toxic substances are due to lead, arsenic, cadmium, chromium, copper, mercury, etc. Prevention and control of water pollution. It can be done by purification of water and avoiding water pollution by protecting water sources. In a purification of water on small scale, purification methods such as boiling, use of filters, use of chlorine tablets, solutions, etc. are done. And in a large scale purification, either slow sand filtration, which is also known as the biological sand filtration, and rapid sand filtration, which is also known as mechanical sand filtration methods are used. Avoiding water pollution from protecting water sources from industrial and trade waste, agriculture pollutants, physical pollutants, and from washing of animals bathed by humans, etc. Purification of a water. Water is purified on a small scale for supply to a city or town. It is also purified on a small scale for domestic use. Purification of water on a small scale such as boiling, chemicals, bleaching powder, chlorine tablets, etc. First one, boiling. It is the most suitable and satisfactory water purification method on household basis, which kills all the bacteria and almost all spores and give purified water. The water should be boiled preferably in some container in which it is to be stored to avoid contamination during storage. Chemical disinfection. Bleaching powder. Chemically, it is a CaCO2 and on standing chlorine tends to leave and the lime remains. A fresh sample of bleaching powder contains 33% of chlorine. To make bleaching powder more stable, lime is added. Such a sample is called as the stabilized bleach. Chlorine tablets. Small tablets are available. They are comparatively stable. One tablet of 5.5 gram is sufficient for 20 liters of water. High taste hypochlorite contains 60 to 70% of available chlorine and it is a calcium compound and much stable compound. Iodine. It is not a routine disinfectant. It is used only in an emergency which may give rise to the diseases of thyroid gland. Filtration. In-house water can be filtered by using ceramic filter, break-fill filter, etc. Purification of water on a large scale. Slow sand filtration and rapid sand filtration. Slow sand filtration is a method which uses supernatant raw water, a bed of graded sand, an under drainage system and filter control valves. Under ideal condition, the filter reduces bacterial count by 99.9%. The steps of slow sand filter are as follows. Supernatant raw water. The supernatant water above the sand bed measures in a depth of 1 to 1.5 meters. It provides an opportunity for natural purification by oxidation and sedimentation. Secondly, water is forced by a gravity downwards to facilitate filtration. Graded sand bed. The sand bed is most important component as this is filtering the water. This consists of sand of different particle size and the thickness. The finest sand is on the top and comparatively coarse sand is below that. Water percolates through the beds very slowly and during this is subjected to mechanical straining, sedimentation, adsorption, oxidation and bacterial action. This filter is called as the biological filter because the surface of the sand gets covered with a slimy growth. Gravel support. Below the sand bed is the layer of gravel which supports the sand bed. The upper part consists of fine gravel and in the lower part is a coarse gravel. Under drainage system. Just below the coarse gravel there is a network of porous or perforated pipes. A system of filter control valves. All the above components are placed inside a box called as a filter box. The wall of the box are made up of stones, bricks and cement. The whole filtration process is controlled by the filter control valves so that filter water is available at a desirable rate. Here you can see the diagram of a slow sand filtration, which is also known as a biological filtration. Now the second method is the rapid sand filtration, which is also known as the mechanical filtration. There are the two types of rapid sand filters, gravity type and pressure type. Gravity type filter is most commonly used. During rapid filtration, 5 steps are involved that are coagulation, mixing, flocculation, sedimentation and filtration. They are considered as an advancement over the slow sand filters and the water is chemically treated before the process of filtration. The rate of filtration is very fast. The raw water is treated with alum in a dose of 5 to 50 mg per liter, and this water is agitated mechanically so that alum can be dissolved and the impurities get precipitated. This is done in the mixing chamber, and then the water is stirred with a slow speed to form big floccules or the precipitate in the flocculation chamber. The next step is to allow this precipitate to settle down at the bottom of the sedimentation tank for 1 to 6 hours. When the floccules settle down, the supernatant water is ready for filtration and the floccules from the bottom are removed from below. The filtration medium is sand, and the particle size of the sand used is 0.6 to 2 mm. Of this is supported by coarse gravel. The depth of the water column is 1 to 1.5 meters. The filtered water is collected through a network of under drainage pipes. After the filtration for 6 to 7 days, there is a development of a layer on top of the filter bed. This consists of the floccules which were not regimented. This layer adsorbs bacteria and oxidation also takes place. Today we will stop here. In the next part we will see air pollution, noise pollution, etc. Thank you very much.